Did you know that the average IT organization spends 80% of its resources just keeping the lights on? That leaves only 20% for innovation, just 20% for new ideas and to drive the business forward. But imagine if we could flip that. Imagine dedicating 80% of our resources to innovation instead. And that's what today's session is all about. We're going to explore how we can shift that balance and accelerate your journey from legacy to production. Hello everyone, good afternoon. My name is Jamie Walker and I'm a principal consultant at Steamhouse. I spend most of my time helping customers modernize their applications on AWS. Beyond that, I'm an AWS community builder and a user group leader for the Manchester user group in the UK. Let me tell you a little bit about Steamhouse and what we do. We're an advanced AWS consulting partner based in the UK, and we specialize in AWS Cloud Native. We help enterprise customers migrate and modernize their applications onto AWS. And we do so using a range of tools and frameworks, some of which we're going to learn about today, to help accelerate things like code migrations and to refactor monolithic applications into microservices. We also put a huge focus on platform engineering and enablement. So we build out in the open with our customers, and we implement frameworks so that they can feel confident operating their newly modernized workloads. So here's what we've got in store for today. We're going to kick things off by unpacking what modernization really means and why it's important. Then we're going to dive into the challenges you might face along the way and how you can prepare for them. My colleague Matthias is then going to talk about how we can solve the problem of legacy code and how automation and AI can accelerate the process. And finally, my colleague Tom is going to share some strategies and best practices for effectively modernizing your applications. So, first things first, what exactly do we mean by modernization? Well, for me, modernization is about evolving your applications and your infrastructure. It's about adapting to the way that technology and our customer expectations keep changing. At its core, it's about faster feature delivery. That means we're giving teams the ability to respond faster to customer needs and market shifts. And for me, most importantly, it's about continuous innovation. And what I mean by that is that it's not a one-and-done process. It's about building a foundation that allows your systems to keep improving and evolving over time. So it begs the question, why should we modernize? What are the tangible benefits that we should expect to see? Well, firstly, when we modernize, it allows teams to innovate faster. Those tasks that take up too much of our time suddenly get streamlined, and that gives our teams the ability to shorten their time to value. Security is another huge factor. Legacy systems often have vulnerabilities that just weren't a concern when they were built way back when. And when we modernize, we can take advantage of the latest and greatest security tools and frameworks. And that makes it much easier for us to then protect our data and meet industry standards. Then there's cost. By updating our infrastructure and adopting modern technologies like serverless and containers, a lot of customers I've worked with were able to cut their operational costs significantly. And those savings don't just disappear, or at least they shouldn't do. They can be reinvested into growth and innovation opportunities. One thing that often gets overlooked is developer productivity. When developers have modern tools, they can thrive. And I've seen teams go from fighting slow release cycles, where they're perhaps deploying once a week at best, to then deploying to production multiple times per day. And when you add all of this together, faster innovation, better security, and lower costs, more productive developers, ultimately this leads to better customer experiences. And I've got some data to back this up. According to a recent survey by TechTarget, organizations that have modernized report that they see a 48% faster time to market. That means that they're nearly halving the time it takes to ship new features. And that can really be the difference between leading the market and playing catch-up. They also see a 70% improvement in application performance. That doesn't mean that things just run faster, but it means better user experiences and fewer bottlenecks. It can also mean that our applications are more cost-effective and sustainable. And perhaps most impressively, they see a 50% reduction in technical debt. And for many organizations, reducing that burden means less time spent on maintenance and more time adding value. So what does a good modern application look like? Well, to answer that, let's take a look at some of the challenges that our customers face and how they've managed to turn those challenges into solutions. Firstly, slow infrastructure provisioning. I'm sure many of you out there have been in this situation. You're waiting for days, if not weeks, to get an environment or some infrastructure provisioned. It's not just frustrating, but it can really impact our release velocity. With modern tools and services like containers and serverless, we can reduce those wait times with on-demand infrastructure. Environments can be ready in a matter of minutes, and that means fewer bottlenecks, less frustration, and better yet, our applications can now scale automatically in response to demand. One of the biggest challenges we see with our customers is manual deployments. They're slow and they can be error-prone, and it makes it really difficult to deploy code safely and confidently. The answer to this is automation. By adopting modern DevOps practices, we can automate everything from linting to testing and deployments through CI/CD pipelines. And this not only speeds up the process, but it also significantly reduces risks. And it means that our teams can then deploy faster, safer, and with confidence. Many teams I work with struggle to clearly define a security posture, let alone actually implement one. And too often, security ends up as an afterthought. It's something that's bolted on later, rather than being baked in from the start. Modernization changes that. It gives us an opportunity to make security a core part of how we design, build, and manage our applications. Another common challenge we see is that teams lack visibility into their applications. Without it, they're blind, and they're left guessing about what's happening under the hood, making it really tough to gauge application health. The solution here is instrumentation. By collecting logs, metrics, and traces, we build a fuller picture of how our applications are running. This makes it easier to identify and fix issues earlier before they start to impact our customers. Lastly, inconsistent tooling. When teams use their own approaches and tools, it creates chaos within organizations. And when we standardize our tools, we create consistency across teams. And that not only reduces the cognitive load on our builders, but it also makes onboarding new team members much faster and smoother. At Steamhouse, we've learned that successful modernization isn't about adopting one new technology. It's about combining multiple factors. And we refer to these as the 5 pillars of modern applications. And it all starts with architecture patterns. Modern applications thrive on modular services. So by breaking our applications down into smaller, independent components, we can develop, scale parts of the system without affecting the whole. And that modularity not only improves agility, but it also helps us to choose the best technology for each part of our application. Then we can define common patterns for things like event-driven microservice architectures and make them accessible to developers to consume and deploy using services like AWS Service Catalog and AWS Proton. A strong operating model is also key to helping reduce complexity. And the goal here is to shift as much of that undifferentiated heavy lifting onto AWS as possible. And we do that by leveraging AWS managed services. For example, migrating our relational databases to Amazon Aurora or our container workloads to Amazon ECS. These services take care of the scaling, patching, and availability of the underlying infrastructure so that we don't have to. We strongly believe in empowering developers. So when we provide them with self-service tools and infrastructure, we can remove bottlenecks. And that gives our developers the autonomy to then create those environments as and when they need them. And that reduces the time it takes to start working on new features, and it also fosters a culture of ownership and productivity. Developer platforms like Backstage can help with that. It standardizes self-service by providing a centralized place where developers can access the tools they need as and when they need them. Things like code repositories, templates, and pipelines. And with Terraform, we can codify our best practices into reusable modules and automate the deployment of our infrastructure. Management and governance. So by embedding guardrails from the start, we help to ensure that our applications are secure and they're compliant. When we use services like AWS Security Hub and Control Tower, they provide visibility and enforce best practices without adding complexity into our environments. And finally, data management. Modern applications require purpose-built data strategies, whether that's DynamoDB for scalability or a more flexible data model, or Amazon S3 for data lakes. The point is we're using the right data store for the job. And as generative AI becomes more prevalent, having that solid data strategy is going to be key to helping you unlock the future potential. So, as we've seen, modernizing can bring incredible value, but of course it's not without its challenges. First up, time and resource constraints. Too many organizations find themselves stuck in that 80-20 trap we discussed earlier, where most of their time goes into maintenance. It leaves little room for innovation. Next, the skills gap. Modernization relies on cloud-native expertise and modern DevOps practices. And without those skills in place, it's easy for progress to slow down or even stall. Then there's budget. The upfront costs of modernization can be intimidating, but we need to consider the cost of doing nothing. Inefficiency, higher maintenance, and those missed opportunities. These are things that can cost us much more in the long run. And technical debt. Legacy systems are inherently difficult to change. All those years of quick fixes and workarounds, often left behind by folks that have moved on from the business. They can pile up, and it makes even the smallest of changes incredibly risky and time-consuming. And finally, organizational resistance. Modernization often means that we're rethinking our team structures, our workflows, and our cultures. It's not just about the technology. People are a core part of modernization. And that's the reality. These are just some of the challenges that we need to tackle head on if we're going to make modernization work for us. Not just for our applications, but for our teams and our businesses too. Okay, so we've bought into the benefits, we've learned about some of the potential challenges. So how do we get started? At Steamhouse, we approach modernization in 3 key phases. This structure gives us clarity and direction, and it also ensures that we're tackling the right problems at the right time. And it starts with the assess phase. This is all about discovery. We're getting a picture of a customer's environment. What applications do we need to learn about? What are the pain points? What dependencies do we need to consider? With that information, we can then prioritize which applications to focus our efforts and define the best path forward. That might be re-platforming, refactoring, or something else entirely. The assess phase, essentially, it's setting the foundation for everything that follows. And from there, we move into modernize. This is where we take those insights and we put them into action. We're refactoring applications, we're building APIs and leveraging cloud-native architectures. And finally, the manage phase. This is where we ensure that everything stays optimized. A tool we recommend to achieve this is the AWS Well-Architected Framework. It can be used pre-modernization to help us understand where our environments don't meet AWS best practices, but also as a tool to continually assess and benchmark our environments as we continue to modernize them. So we've spoken about laying the foundations of modernization, but there's a challenge that keeps repeating. It's one that often stops us in our tracks before we get started, and that's legacy code. And here's a stat that really drives this home. According to a recent survey, 50% of the JetBrains developer community are still using Java 8. That's a version that was released almost a decade ago. And it's not because developers don't want to upgrade, it's because it's incredibly difficult. It's a clear reminder of how challenging code upgrades can be, and while legacy systems often linger on far longer than we would like them to. And this is exactly where automation comes in. Automation can be a real game changer to handling the grunt work of code migrations. Upgrading dependencies, running tests, refactoring our code, the stuff that eats up all of our time and our energy. And with automation, we can tackle those tasks faster, with less risk and much more consistency. And ultimately, that's how we start to flip that 80-20 dilemma on its head, much sooner. And where automation really shines is with legacy code bases. So to show us how we can approach the challenges of legacy code, I'm going to hand over to my colleague, Matthias.
Thank you, Jamie. Hello, everyone. My name is Matthias Gmaris. I am Coding Matthias everywhere online, Senior Developer Advocate here at AWS. And I want to know who here is actually dealing with legacy code. So raise your hand if you are dealing with legacy code right now. Okay, quite a few of you. Raise your hand if you love it. All right, good. A lot of sensible people in the room. I thought I saw a hand over there. But yeah, I mean, legacy code is difficult, but also it gets very tricky when you take a step back and try to think about it more philosophically. After all, what is legacy code? So if you look it up, you get these results. It said that legacy code is outdated computer code that is no longer supported nor compatible with current standards. Now, I love this definition because there's a lot of emphasis on code being old, but there's nothing inherently wrong with code being old, as long as it works, right? Certain parts of Windows still run on code that was written decades ago. Same is true for Linux. A lot of the foundational code in Linux is still the same that was written in the 70s. And it may be surprising for some to know that the large percentage of daily transactions that are conducted by financial institutions today are still running on COBOL and mainframes. So how is this possible? So how can you actually run all these applications? Well, you see, there is a difference between old code and outdated code. So that is the key word. Because once your code becomes outdated, you lose the ability to do very important things, crucial things to software development. The first one, to patch your code base, to make sure that it's up to date with security standards and vulnerabilities and attacks. And the second one, perhaps even more important, although security is always the most important one, building new features. But as we know, innovation and security are cornerstones of our modern landscape right now in technology. So you definitely don't want to compromise on either of them. But then how does that work? How do you get these products and services still running these legacy codes in production today? Well, the thing is that there's also a difference between outdated code and outdated code bases. So if you have a modern code base, you can have outdated code, legacy code, as long as you, one, keep it to a minimum, but two, keep it wrapped. So when you got a modern code base, you can wrap that old code, the legacy code, inside, and that way you can still keep up with your security standards, and you can also keep taking advantage of modern technology, such as generative AI, for example, right? So you can use try and tested design patterns, such as adapters or strategy or facades, to make all that work and create complex interactions between your legacy code and your modern code base. And you can just make sure that that code stays isolated from the bigger picture of your application while you continue to develop on top of it, right? Even if you do that, there is a third problem that you're going to have to deal with, and that is performance. Now, performance may be a more acceptable compromise and also something you may have control of. And depending on what you do, it may not even matter that much if there are a lot of async operations in your application, right? Having said all that, this does not look great, does it? Like, you definitely don't want to make all these compromises. And the plan should always be that you go for migrating your code base fully and then work backwards from it to identify the exceptions, right? And the problem is, if I'm going to migrate my code base fully, how am I going to find the time to do it with so much going on, right? So what do? Do you just consider all code migration problem technical debt and then drip feed the changes into the backlogs? Or do you take, for example, a ratio approach and you go, okay, I'm going to do 20% of all my sprints, co-migration stories. Everything else, we keep on developing new features and writing new solving bugs until hopefully all that code is migrated over time. Or you do intermittent sprints. So you're going to do full sprints on co-migration and other sprints on new features and bugs. Now, in the past, I've been in this business for like 25 years. I've seen all kinds of approaches, and I have to say, ultimately, they don't work. Not with co-migration. Going slowly but surely works with refactoring code, not with migrating code. So if you are refactoring from a monolithic code base to a microservices code base using Strangler fig pattern, fantastic, right? That's what the pattern is for, going slowly but surely, and that works great. But the pace of modern technology will definitely outrun any co-migration effort you have if you keep going too slow. So what's the solution? Well, the solution was always around. It's to migrate the code as fast as possible. Because if you don't, you expose yourself to higher chances of disastrous consequences, such as in 2012, when Knight Capital lost almost $440 million because a no piece of code got reactivated by mistake because it was just living inside the modern code base. And that old piece of code is start trading thousands of erroneous trades. And this is still considered one of the most expensive software bugs in history. And you think that's bad? How about this one? In 1999, the Mars orbiter got completely destroyed when entering the Mars atmosphere because there was a piece of legacy code in the modern code base. This one was nicely abstracted away and actually wrapped. But the altitude was calculated wrong because the old code calculated in imperial units and the new code metric units. How stupid is that? And so much money, so much time wasted. Because sometimes it's not just about the technical aspect of it, but the logic, such as the different units used by these different code bases. So what do you want to do here? Well, you have to figure out the best way for you to move forward for as fast as possible so you can actually get that code out of your modern code base. And even if you're going to keep that code around, I would still suggest that you keep it to a minimum, as I already mentioned, and also to basic operations, like doing math. Although, as we're just saying, sometimes even that can go wrong. So what do? Migrate everything fast. Well, duh, easier said than done, right? That's obvious. If you could do that, then all problems will be solved. Except that in 2024, that is actually becoming possible. So this was easier said than done until recent times, but we live in magical times. And now we are able to do this because of the rapid acceleration and innovation of AI. So with AI now, we can really up that level of automation that always existed there anyway, as a narrative, as a flow, as a thought, as a strategy, much like Jamie pointed out earlier. But now we can actually execute on it very fast with tools like Amazon Q Developer, which allows us to go through thousands of lines of code very quickly and then migrate them to modern code. So Amazon Q Developer, code for agent transformation, it's a very long name. It's specifically a capability of Amazon Q Developer that you can use to migrate code. For now, it can migrate from Java 8 and 11 to Java 17, but it's no secret, we already announced it last year, last reInvent, that this was coming very soon, and I can tell you very, 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 very soon, if you catch my drift, wink, wink, to .NET. So you're going to be able to migrate from .NET Framework to cross-platform .NET. And there's massive cost-saving potential there, because that means you can take the applications that you run on Windows servers right now and run them on Linux by migrating very fast using Q. Now, Q will also migrate your code while adding best practices to it. So sometimes it's not just an upgrade in syntax, but also an upgrade in quality. And it can take into context, certain projects, the whole code base. You can do whatever you think's best there. But let me show you actually then how it works. The first thing we're going to do is actually migrate the code base. Seems like that is the end game, right? But no, now it's just one step. It's the first step, because after migrating, you want to modernize, right? And that's what we're going to do. And Q can help you with the whole thing, with the whole software development lifecycle. So I'm going to take a code base, and I'm going to upgrade it from Java 8 to Java 17. So here is a project that I have, very basic, on purpose, just for the purpose of the demo. This is a calculator project done in Java, and this is written in Java 8, and I have the code file, and there I have the test files. So I only have 2 unit tests, but that will do. I'll go to the Q button right there in my IDE, and I'm going to type /transform. /transform invokes the agent to do code migration. It's going to ask me for the project and the target and the source, so Java 8 to Java 17. Then it's going to ask me for the Java SDK 8 in my machine so that it can go and run things behind the scenes. While it's running the code migration, it gives me a plan. So I can look at the plan step by step to see what it intends to do. It's going to keep populating that with changes and links for me to learn more and have a look at code migration in general. Then, once it's done, it's going to ask me to download the proposed changes there in code. So I click on the button, and I got all the files that will change, not just new files, existing files as well. And once I click on them, I get just a standard diff on it. So here I'm migrating from Maven 1.8 to Maven 17, and even upgrades the dependencies like JUnit to it and any other dependencies that are needed. And you can continue doing that and accepting changes manually or all in one go. And you'll see here that it also upgraded the syntax, so that's using Java 17 syntax. So it's not just about the configurations and dependencies, but the code and everything else there. So as you can see, very simple. You can migrate thousands of lines of code doing this. It can, of course, the more code you have, the longer it will take. But you can literally migrate code bases that will take months, weeks, in hours, or minutes even. No joke, for real. But now we got code migrated. Who would have thunk that that was only the beginning? We want to modernize. We want to then perhaps up the code coverage, or we want to not just add more code for the new stuff that got generated, but also just take advantage of the new capabilities in Java 17 to make this better. So let's do this. So I'm going to go back to my project. That's the same calculator project that I had before. And so I have there my code. So that's just doing simple operations, right? And then my unit tests. Not many again, just addition, subtraction. So we're going to add a new one. So the first thing I'm going to do is highlight that. And we're going to pretend I'm like a junior developer. I don't know much about unit tests. So I'm going to use the feature explain. So Q can explain code, not just what's open, but like your whole code base as well, which is great if you're jumping from repo to repo as a developer. Or if you're like a junior developer getting onboarded, or anybody else. So it gives me a good explanation of what the test is doing. And then I can go back to my code, and I'm going to highlight the method that I want to generate a unit test for, in this case, multiply. And then I'm going to go to Q and say, can you generate a unit test for this? And not only is it going to actually generate that code for me, but it's going to explain everything. So this is the other thing. It takes that concept of learn by doing to a whole new level. You're not leaving your IDE. Everything is there. It helps tremendously with concentration, productivity, and you're learning and getting the code at the same time. So that's one way to generate it, but there are many different ways to do this. The other way that we can do is by going back to the code base. And here, what we're going to do is just start typing and use the super smart auto completion, right? So I'm going to start by going add test. And it's going to take into context my whole file that I have open and go, OK, this is a calculator program. You got 2 unit tests, one for addition, one for subtraction. So I think what you want is this. And indeed, I just keep tabbing and accepting. And before I know it, I'm done. And that test is done, plus division, like that. Now, I'm not going to just trust it, right? I'm going to run it. So I'm going to go back now to my IDE, and I'm going to verify this. I'm going to make sure that the build is still good and the tests still pass. And indeed, they do. So it's very aware of syntax and the overall code context and make sure that everything passes. Now, lastly, as you can see, I just want to show you they can also generate by using comments as prompts. Much like you would prompt a chat, you can just add the comment, test divide by 0, and then it generates the full test for you just based on that prompt. Once again, we run, and everything is OK. It passes. OK, so let's add some documentation. So very easy again. I go to Q. And this time, what I want to do is add Java docs to this, right? And all I want to do is make sure that all these methods, all these tests, have an explanation about the parameters, the inputs and the outputs. So I just go to Q, and I say, add Java docs. Now, this is a complex operation, so I'm using /dev, because it's going to touch many different files in many different ways all over the place, right? It's not just one file. So I go and do the /dev to add the documentation, and it's going to give me the explanation of what it's about to do. And again, this is a complex operation, so I need to make sure I'm happy with that first. And once I review it, I just go, sure, write the code for this. And then once it writes the code, I'm going to get kind of the same flow as before, except that I have an opportunity here to provide feedback and then keep iterating and generating through it. Once I do that, I get diff version there, much like everything before. I can just accept the code as a whole or accept individual ones. And as you can see, it figured out where to put those comments in every one of those methods and the information that I wanted to add. I'm going to just accept the changes for this one to make it quick. And then once I accept the changes, I have all my documentation there. So lastly, just security, right? You want to up your security. You got modern code base. You want to make sure that your security is up to scratch. So what we're going to do, and this one is incredibly easy and quick. You just go over to the command palette here of Q, and we're going to find all the security issues that we have. And it's going to scan the whole thing for us. Now, I have a different application here, something more complex. This is a web application, which I purposely put a lot of security issues there to see if they come up. And then all I'm going to do is go to Q, and I'm going to ask to scan my project. So run project scan right there. That's all I need to do. I'm going to leave it running behind the scenes. And then once it does, depending on the size of the project, it may take a little bit longer. But once it does, you see that you got those yellow squiggly lines on the code that you can hover over, or you have right there a list of all the security problems that you have. And for example, here we have limit request length. If you're not familiar with the security risk, you can just read about the details. You can see a little bit more explanations by going on explain, and again, getting that interface that is telling you a little bit more about it and going deeper into it. And you can see other links such as quick fix and even more information about the problem in external sources as well. Now, this is the classic SQL injection one, for example, that many developers forget. It can pick that up for you, and it can actually help you fix it. This one is the log injection one. So it goes deep. It understands what your code is doing. It's not just about the simple security features, or such, for example, not doing a try and catch. It goes deeper than that in context. In this case, it even picked up cross-site request forgery. So it has an explanation. I ask to go deeper by clicking explain. Now, it's not only going to generate the explanation, but also all the code that I need to fix it. So that's just a quick tour of the Amazon Q Developer Code Transformation, Code Agent for Transformation. This is incredibly powerful, and it really can help you speed up through those code migration stories. Like I said, depending on how you approach it, it doesn't matter the project methodology. Ultimately, the how, it's being very much solved by tools like this. AI is making this very easy for your developers. Who is a developer here? Who is actually a developer? Okay, cool. So hopefully as a developer, you'll be able to appreciate that this can, to begin with, cut your research time in half of things that you need to upgrade and fix. And then you just keep on taking this further and further to modernize. So this is a bit of the how. But now, how do you actually approach this? How do you actually make this happen and add that to your projects and applications and make sure that everything's ticking and going the right way and so that hopefully you're free of migration issues. And to do that, I invite my colleague Tom on stage. Please, come on. There it is.
So, thank you, Matthias. It's really great to see a demo of product in action, much more useful than just talking about it, but actually seeing how you can start to apply that, how you can start using that yourself. So, where next? We've had Jamie setting the scene and what we see with our customers and their modernization journey, why they modernize, what those business and technical drivers are for modernization. Then we've had Matthias come in with the demonstration, really walking through how you could do that with a legacy Java app. And I'm going to round off the talk today looking at what your next steps could be, how you can incorporate Amazon Q Developer into your workflows, into your work streams, and how you could include modernization in your 2025 roadmap. First things first, who am I? Well, my name is Thomas Yukanis. I'm a colleague of Jamie's at Steamhouse back in Manchester in the UK. I've been in and around the tech industry for 20 years now. I started my career in the Wild West days of the post.com boom. My background is as a developer. I started working with AWS around 10 years ago. Initially, found the joy in throwaway infrastructure, but then I could see I could do more while writing less code and embrace serverless and AWS Cloud Native. My role now centers around helping our customers migrate to and modernize within AWS while building internal capability so they can continue that journey. So how can Amazon Q impact you directly? I'm going to approach this from two angles. Firstly, let's look and see if there's a threat to us as architects, as builders, developers, from Amazon Q and the new wave of Gen AI capabilities within AWS. We're technical people. We're likely working in cutting-edge organizations using modern technology to deliver value to our customers. Could we be ripe for replacement? Secondly, I'm going to look at how you can bring what you learn here at reInvent back to your teams, strategies you can use when you go back to your organizations and want to start getting hands-on. So, all of you watching this talk today, I like to think of as change makers. Regardless of title or experience, you're here today because you're not just because you are interested in fostering change within your organization. You're not just turning up looking to maintain code, add features, or do things in the same way as been done before. You're looking to explore new ways of building, new technologies, looking at how to leverage those technologies in your career. The evaluation and utilization of new tech is how we keep ourselves and our careers fresh. It's important to understand how to use new tools as they become available, where their strengths lie, and how they can help you be better at what you do. So what does it bring to developers? Well, Matthias demonstrated a few moments ago how you've got a tool that can help you automatically upgrade applications, generate transformation plans, assist in testing and validation of code migration, incorporate AWS best practices. Now, we've all seen sensationalized headlines proclaiming AI is going to replace us. But let's look at how writing code has developed over the years. Using an assistant like Amazon Q Developer doesn't mean the code you ship is no longer your own. Look at packages, look at dependencies. Does including them mean you lose control of your applications or your code? No. It means you're not reinventing the wheel, not writing simple code that's been written before. What about frameworks? Did they replace you? Again, abstracting logic away to a framework doesn't make your application any less your own. Using libraries, using frameworks allows you to concentrate on writing the code that matters, the code that differentiates you from your competitors, allows you to focus on the logic that delivers what your customers need. So, will Amazon Q replace you? My short answer is no. My longer answer is that tools like Amazon Q Developer become assistants to you. They shouldn't do everything for you, but they give you a leg up. Look at something as simple as the tool you use to write code. You could use something as plain and simple as a plain text editor. It will do the job. But most of us use fully featured IDEs. Things like VS Code can be customized to the languages that we use. It's extended through a vast array of plugins. And there are various tools that have assisted in linting, commenting, and auto-completing the code that we write. The new wave of Gen AI products from Amazon Q Developer should become another tool in your development toolbox. I'm not doing the same things in the same way as when I started 20 years ago. And in my opinion, one of the greatest things about working in tech is that things are constantly evolving. We have a steady line of innovation that keeps us on our toes, keeps us learning. Experience isn't about doing the same thing in the same way again and again. It's having the knowledge and the confidence to explore new ideas, new tools, new methods of working, and evaluate their use. So one of the challenges to modernization is working out where and how to start. It's easy to trip up and want to understand the absolute target state architecture. There are over 200 services in AWS and thousands of features, and beginning this journey can seem overwhelming. When modernizing in AWS, it's important that we have clarity of our destination, but also flexibility to adapt as we learn and uncover new information on that journey. So when we look at where we want to end up from a technical perspective, we know it's important that we have that clarity around what it is you're solving. What are those pinch points, those issues to be fixed? Make sure they're aligned to your business goals and make sure they're aligned to the value to the organization. So you could be reducing technical debt. You could be improving release velocity. It could be about improving the resilience of the system, about improving elasticity, or just putting you in a better position to foster innovation. Having clarity of the ultimate end state, be that microservices, containers, serverless, introducing ephemeral environments, by having that clarity of the broad end state, you can then start to break down that large digital transformation piece into smaller, achievable goals. It also gives you a fantastic opportunity to bring in the wider team. I'm not talking about architecture by committee, but by sharing your vision and listening to the people that work day in, day out on the products you build, you'll get fantastic insight and bring new perspectives to tackling existing problems. As I said earlier, experience isn't about me having all the answers immediately, but having the confidence to be challenged, listen to others, and find the best solutions. So at this point, we've talked about the importance of laying a solid foundation for modernization, getting a clear picture of your application, building a strategy, and managing your system long term. But how do we take that first step in a way that's impactful and keeps momentum going? At Steamhouse, we use the AWS-developed ModAx transformation methodology. This accelerates modernization in the cloud and is based on learnings from thousands of customer migrations. ModAx is an outcome-focused initiative that takes just 6 weeks to deliver tangible results. Unlike a broad strategy phase, ModAx zeroes in on a small, high-impact application to kick things off. And it's not just about planning. It's about getting builders hands-on with new technologies from the start. The goal is to create a quick win that sets the tone for your entire modernization journey. By starting small, teams get the chance to experiment, learn, and adopt best practices while making immediate progress. It's an accelerated and highly focused way to get moving on modernization while ensuring builders are directly involved and gaining valuable experience. So what does it look like in practice? Earlier, Jamie spoke about three phases of modernization, and ModAx EBA is a focused, tried and tested methodology to approach those 3 phases. We begin with that assess phase, deep diving into a group of applications, or maybe taking in the estate as a whole before refining down to a targeted specific. We work with teams to understand pain points and challenges. These could be issues frequently causing downtimes, very visible to the wider business, but can also include those issues lurking under the surface, known only to the developers, but not yet causing those outages. There are different ways we can identify the initial modernization candidates. Based on our understanding of the pain points and challenges faced, this could be something that's a current pinch point, frequently failing and requiring a lot of manual intervention. At the other end of the spectrum, The impact could come from its position as a small, easily extracted application, pitching that as an ideal candidate for the team to try new ways of building. So once the assessment has been complete, target state architectures created and aligned to modernization pathways. Planning and enablement begins. Where skill gaps are identified, we'll run workshops, immersion days, AWS deep dives into specific services. When building begins, we look to fail fast and document. Build out that initial MVP and get feedback. The targeted business outcomes of ModAx is the ability for the customer to continue independently. This introduces the concept of creating modernization muscle by unlocking modernization activity, performing base-level enablement, and providing a structured, experience-based learning through the delivery of the MVP. We often work with customers to build out architectural patterns that can be reused independently while working on a new service and features in a continued EBA. Excuse me, sorry. So, much like QDeveloper can be a tool that you can use, there are other tools available. One that we use in our experience that we've found making EBAs really successful is vfunction, which can decompose a monolith into AWS Cloud Native services. And what's great about vfunction is it uses runtime dynamic analysis to find the business logic and automate the domain design and modernization plan. Now, this then aligns with one of AWS's modernization pathways, which we'll take a look at now. So we've spoken about the importance of using the right technology for each part of our application. ModAx helps us making those technology decisions by employing one or more of the predefined modernization pathways. Move to cloud native. So this pathway is focused on that monolith decomposition and breaking down into loosely coupled microservices, enabling agile and scalable architecture. Move to containers. That's about operational efficiency, portability, and consistent environment through the use of containers. This could be containerizing existing applications or moving existing container orchestration to fully managed Amazon ECS or Amazon EKS. Moving to managed databases. So we're moving away from self-hosted relational to Amazon RDS, Amazon Aurora, but then beyond to AWS's portfolio of databases. Free up how and where you store data with purpose-built solutions for targeted use cases. Move to open source. This pathway focuses on moving existing workloads tied to expensive licensing models to open source, so you can experiment more and move faster without having the restriction of those expensive licenses. Moving to modern analytics, this pathway revolves around the idea of helping customers with their data lake requirements, focusing on data warehousing, data processing, and real-time analytics. Moving to modern DevOps, so this pathway, customers are looking to integrate modern DevOps practices and move to modern operations with automated pipelines. By leveraging AWS's development tools, organizations can further accelerate their digital transformation journey, delivering applications faster, more reliably, and at a lower cost. So just as there are tested methodologies for modernization, there are also proven strategies for refactoring. Vertical slice refactoring is an architectural approach that organizes code changes around complete business functionality rather than technical layers. Instead of making changes horizontally across all similar components, you implement and refact features in complete vertical slices that cut through all layers of the application, from the user interface through the business logic down to the database. This approach delivers immediate business value because each slice represents a complete working feature. It also reduces integration risks since you're continually integrating across layers rather than waiting for a big bang integration at the end. The practice promotes better collaboration between team members with different expertise as they need to work together to implement the complete slice. The strangler fig pattern was introduced by Martin Fowler as a way to manage risk when modernizing and rewriting large monolithic systems. The pattern is named after the Australian strangler fig, a plant that grows around another tree and eventually replaces it. In software modernization, the strangler fig pattern works similarly, with new functions added step by step until the new system fully replaces the old. Initially, a proxy is established with pass-through behavior to the existing monolithic application. In this example, AWS refactor spaces can be used to provide the infrastructure, multi-account networking and routing that you need to modernize incrementally. Here, a new service, decoupled from the original, is created. The proxy is updated to route traffic to that new service. This can be an extremely low-risk strategy. The existing monolith remains untouched. If issues are found during migration, the previous functionality can be switched back immediately. This pattern of proxying, then swapping out the old with the new, can continue until all legacy systems and functions have been replaced and the legacy system can be decommissioned. So, when refactoring, when modernizing, it's important to remember, don't attempt too much at once. Start small, reduce risk, and prove value. Use tools like Amazon Q Developer, modern CI/CD tools in AWS. Create repeatable, safe deployments. Use infrastructure as code. Ensure that you can repeat and recover. Take the opportunity to introduce developmental cultural change within your organization. Remember that your modernization efforts are driven by business need. They involve key stakeholders across the business and celebrate successes. Measure everything. Understand the impact of the changes you make. Track performance both at an application and a team level. Use data to demonstrate the positive impact of modernization. So going right back to the beginning of the talk today, the average IT organization is spending 80% of its resources on the operations and maintenance of existing applications and only 20% on forward-looking innovation. Tools such as Amazon Q Developer and methodologies such as ModAx can help you turn that ratio on its head. They can handle the mundane, freeing you up to deliver value faster. Migration and modernization can be surprisingly simple, but it also can be incredibly complex. But remember, start small and think big. You're not alone. Organizations across the world have already begun their modernization journey. There's a very good chance AWS have seen that edge case before. If you have them, speak to your account managers, talk to partners, engage in your local AWS communities, talk through the problems you face, and you will find answers. I'll just invite Matthias back up.
Right. Well, thank you very much, everyone. We are going to be hanging around here after for questions if you want. The one recommendation I have is check out Skill Builder, especially and workshops as well. There's a lot to do with code migration there, not just Q, but also to do with the bigger picture, monolithic to microservices and all that stuff in between. But yep, just want to thank my colleagues. Oh, I turned it off instead of going forward. There you go. Yeah, I hope you have learned something new today, and I hope you enjoy reInvent. Thank you very much.